My name is Joe. We work on a protocol called Witness. This presentation is basically 15 minutes of a high-level overview of kind of what this protocol is, why we think it's interesting, how it works, et cetera. And then we're going to go through a little bit of a workshop that hopefully will be a little bit interactive. We'll let you guys kind of play with the MVP app we have, understand how application developers can interface with the protocol as well, because that part of this architecture actually differs a lot compared to most blockchains. So it'll be something we're important to highlight. As I said, we'll go through what this protocol is, why we think it's interesting, demo some use cases, and yeah, anytime you guys have questions, just feel free to raise your hand. We can run through it. I think you both are familiar with our backgrounds, but just for the sake of the recording, my name is Joe. I was previously an investor at Framework Ventures. I've been on-chain for the better part of the last decade, and I'm very passionate about extending on-chain guarantees to the rest of the internet. Sina, also very passionate about that idea, spent previous time as an engineer at Paradigm, Google, and Meta. I think he's one of the better Solidity engineers in the space, if not the best. So what does Witness Protocol do? We start this anytime we're kind of introducing the protocol to people, especially at an event like this where people are focused on the various layers of these blockchain resources. What are they able to provide to us? Different ones of these layers or multiple of these layers can provide us some similar resources. And so when we think about what those resources are, you can obviously get execution from a blockchain. You can also get this kind of DA, data availability resource. And at Witness, what we were really interested in is actually this resource that we believe is kind of a nerfed version of data availability. But because it's nerfed, we can significantly reprice it, which means it's more accessible for developers. And this is kind of the lens that we view through. So like, what is Witness? It is extending the data existence property of blockchains. And if you guys have questions around what that is, I can kind of get into that in the next slides. But we're creating trustless timestamps at scale. There's kind of two portions to this protocol. That's why we don't call it a blockchain, is because not everything is happening on chain, and that's actually the nuance of this architecture. And so two things are happening. Off chain, we have users that are essentially receiving proofs from an API interface, and these proofs are basically sovereignly verifiable, trustless timestamps. On chain, we have a set or a series of smart contracts that periodically verify and update the root hash of this data structure that we're basically adding hashes to over time. And I'll get into kind of the specifics of how that operates. But when we think about like, okay, feel free to hop in, no worries. Welcome, welcome. No worries. When we think about what Witness is, this off-chain component operates as a verifiable data structure. And does that like ring a bell for you guys as far as like what a VDS is? It's essentially a data structure. As you manipulate it, you can verify basically the manipulations that you've made to it in some ways. And specifically, this operates as a Merkle mountain range, which is a specific type of Merkle tree. We'll get into why those properties are interesting for the protocol here in a bit. And then also off-chain, there's this Web2 API, an interface for application developers to basically send hashes of information to and retrieve proofs from us. On-chain, we have an immutable smart contract, and this same smart contract is actually deployed across many EVM networks. Right now, we're live on Ethereum, Optimism, Base, like basically every major testnet as well. And what's happening here is essentially, I think I actually get into this next slide, which might be a better portion for it. But this Merkle mountain range is essentially getting checkpointed against this immutable contract. That's what's happening on chain. It gives us these nice properties that we'll kind of chat through. First thing we want to kind of like center the room on, especially like in a space or a conference where people are talking a lot about scalability, is this kind of broad question of like, why isn't everything on chain? And when we think about like what my answers would be or what kind of our opinions at Witness are about this, it's kind of this aspect where there's always this kind of initial and upfront cost you have in order to interact with these permissionless dynamic markets, right? We're very familiar with the fee market dynamics on a network like Ethereum, even a network like Celestia. You have these kind of priority fees where as more people start using the shared resource, it becomes more expensive for everyone. And so there's kind of this diseconomy of scale that occurs. And the reason Witness's architecture makes sense to us is because although it creates a new trade-off space, part of the output of that trade-off space is the fact that this thing is essentially, we can amortize the cost of one dynamic consumption of on-chain resources to represent many off-chain artifacts. And candidly, like when I say many, I mean like millions, tens of millions, hundreds of millions. And so a lot of what we're thinking about is like, okay, when you're in a room with someone or maybe taking a selfie or something, what's preventing people from like minting these things at that scale today? Where applications might be thinking like, oh, I meant one thing per user session. What allows them to think differently about basically receiving this resource of hardness from blockchains at a different scale? So removing that glass ceiling is something we're interested about because I think we've all seen it, but like almost all of the applications we're using today are like inherently financial in nature. And that's because there is this upfront cost to leverage these resources. Any questions, just as I'm kind of running through things, just want to get a sentiment again?
So just curious when you said proofs, you use the proofs with the proofs that you're talking about.
Yeah, so you're talking about, like, could I maybe give some more context into this proof word that I'm using that I haven't described, so thank you. Essentially what this proof is it is a Merkle proof that resolves to a checkpoint, and that Merkle root represents this verifiable data structure that we have access to off-chain. And so the way to think about it is that as soon as we land a checkpoint of this Merkle root on-chain, we can produce a proof that is the Merkle path that allows a random hash that someone's trying to prove to resolve to the chain. So I'll kind of walk you through like some of this in some of the upcoming slides, but it's a great question, and we probably should have started with that a little earlier, so thank you.
So it's proof in the Merkle document.
Correct. It's basically proving that this thing was included or witnessed at a certain time. That's like one way to think about it. What does witness do? It allows you to prove to an untrusting party or an on-chain contract that a specific hash of data was witnessed and maybe hasn't been modified since that point in time. A great question. Thank you for that. And yeah, why are we building this? We think if we extend the hardness of public blockchains, and using this word hardness, it means this verifiability. Well, we think if we have the potential to extend that to the rest of the internet, we can accelerate the adoption of public blockchains as these universal standards for coordinating around things like ownership, truth, et cetera. And like some of you might have seen this tweet, but this like really hits for people, I think. So it's like worth summarizing. Like, why build witness? What is it? This is actually the only part where blockchain really comes into play. Is this like verifiable ordering? I could just verify a signature that you make to me off chain. I don't need a blockchain for it. And so we think this is actually this like really novel property that we need to find ways to extend and incentivize people to leverage. So hopefully that captures it succinctly for you guys. Do you maybe want to kind of chat through your perspective? Because I feel like you do a good job describing this one. I can hold the mic for you, but
yeah, sure.
It's going to not extend too far. But.
Yeah, so this is kind of an interesting graphic that we... So basically what this graphic is trying to describe is like this sort of overlapping Venn diagram of what data you can actually sort of express in sort of a Web3 way, quote unquote. So obviously the smallest circle just has the data you can post on chain without DA. Think of like call data rollups, stuff like that. Then you get like 4844, sort of like aligned DA, maybe even you count eigenlayer in there. You also have like the unaligned DA. So like the circles are getting bigger as you sort of almost like degrade the DA relative to like the base layer that you're looking at. Like you can see, or sort of even factor in like some of these more like centralized DAs, data availability committee, stuff like that. But kind of the punchline of this graphic is that no matter how many of these like DA layers you stack on each other, A, you're kind of degrading what it even means to have DA at a certain point, and then B, like at the end of the day, you're never gonna really hit internet scale for sort of data that could benefit from being sort of interoperable with the chain effectively. So making more data portable, you don't necessarily need DA, you can just do it via like witnessing it, which is what we built.
Thanks, sir. Any questions on this graphic? Because I think this does, again, it does a good job of like succinctly describing like the why. Like,
Is it possible to build this kind of like DA waterfall, or are they always going to be like separate layers?
Do you have any thoughts on that?
Can you say it again, DA waterfall?
Yeah, I feel like it's like, can they be like fully integrated or like?
Yeah, I mean, I think one way to think of it is like, what's data that's never going to benefit from sort of, or never is going to make sense to be made available, right? Think of like tweets or like Discord messages or Farcaster casts, right? Like, would someone make a post on social media if it costed them a cent, 10 cents, those kinds of things? Probably not.
But an application developer develop an application if they know like an end user is going to always have to pay an upfront dynamic fee that they might not necessarily control.
Yeah, but I'm more talking about this. I mentioned where waterfall. Like, is it possible to do this something like you just everything is just witnessed, and then like over time, or
yeah, I mean that's kind of
choose over time how much security or how long we want to.
Yeah, and kind of part of the thesis here actually is that you don't need DA for a lot of cases, which I think is exactly what you're getting at, where you can have sort of different types of dynamics. In a lot of cases where you have like a data availability committee, for example, like would it be better if you just had like some kind of witness timestamp and then you as a user just custody your own data, right? Maybe that's even better than delegating it to like this committee of companies or whatever. If it's obviously the application being a model where you can sort of get away with users custodying the data, but
I'm also talking about like, are we moving where like selective pruning or something, like where we have some hierarchy of data importance, like something actually gets on Ethereum while others are just some alt DA.
Yeah. Yeah, I mean, that's kind of exactly what this gets at.
Yeah, the only thing I would like modify about this graphic is like when we think about like the actual we're trying to represent like the size of data with these different like circles here. Arguably, if we remade this graphic, I would make this one like 99 times bigger. In the sense that like, okay, we think about like what percentage of the internet, like the data on, or of data on the internet, like exists in these 3 buckets. It's like less than a basis point probably. Like when you think of the percentage, and a lot of what we're saying is that like, hey, there's all this other stuff on the internet that can benefit just from this like even very light guarantee of this like data existence guarantee. It can allow applications to think differently about how they coordinate and potentially how they compose on chain. Cool. But great questions, I appreciate it. So let's kind of break down like how Witness works. We've kind of described like why we think this thing is interesting. It gives you, a different scale of access to this resource that blockchains quite uniquely provide. And so the way that we kind of break this down is there's like this 5-step game that's happening. We have an app user, we have the Witness API, and then we have like the actual on-chain protocol. And I'll walk through each of these steps, who are the actors involved in each one. But the first thing we have is that a user is submitting their data as a hash. Notably, the underlying data that is represented by that hash is never shown to our protocol. It's never relayed to our API. So there is some like nice privacy properties we can chat about later with regards to that. What the API is doing is that it is essentially aggregating hashes from any client that is consuming this service. So, if Sina's sending me 1,000 hashes and some another 5 applications are all sending me hashes, we're aggregating all of those into essentially what is a new Merkle root of this tree that we're operating off chain. And one way to think about that data structure is it's the append-only list. We're basically saying, hey, during this epoch we added these events. Those events are all individual unique hashes. Periodically, that API is submitting the new Merkle root that we've arrived at. We say, okay, we've waited 5 minutes. Perfect. We're going to aggregate all of this, take that new Merkle root, and we're actually going to broadcast it to the chain. When it gets broadcasted to the chain, the protocol is doing 2 things. The first thing it's doing is it's verifying a consistency proof that ensures that all we did with this new root checkpoint is add new leaves. So it enforces that append-only aspect of this verifiable data structure. Okay? The other thing it does is that obviously we're paying for this data availability resource when we go and broadcast this transaction. A nice byproduct of that is that this root checkpoint gets broadcast for anyone in the world that wants to see it. Okay? So we publish this new root, and that is actually what allows us to coordinate around these off-chain proofs. So we have this checkpoint on chain, right? What's happening here? Once that lands on any of the chains that we support, a user can then come in and request this Merkle proof that I was mentioning earlier that you were asking great questions on. And that Merkle proof is actually the trustless timestamp. Once we get to the end of this flow, like what are the key things to kind of take away from it? The first is that only the protocol is paying a static amount of gas to update this thing. And so the idea is like even if there's 1 million hashes being submitted during a certain period of time, the costs associated with that, with air quotes, can be amortized across all of the clients that are gaining benefit from that, right? The gas usage, so the amount of gas it takes for us to process a transaction at the protocol level is always around 90,000 gas, depending on some dynamics there. Yeah, so if the priority fee goes up and down, you're absolutely right. But we're still only being exposed at a static gas usage. So if I have one proof that I'm adding, one hash that I'm adding to this verifiable data structure, I make a Merkle root, I bring it to the chain, I'm paying 90,000 gas. Yeah. If a huge application is leveraging this and there's 1 billion entries into this tree, that gas usage is still 90.
I understand it as a technical point.
Yep.
And I think it's interesting to have this in mind that it's a static 90,000, for example, gas fee, but it's not interesting for an app user, for example, who wants to implement your protocol, in the sense that they don't really care. Like if you tell them, okay, each time you're going to pay because it's amortized on unlimited protocols, you're going to pay X gas. It's like, okay, I don't care about the number of gas. I care about how much I pay.
So I'll add some dynamics here. The first thing is that we're not charging people on a per entry basis. The idea is that we want to basically turn what is a dynamic and upfront market into a static cost for applications. What could that look like? Right now, we're trying to get people to experiment with this primitive. If you want an API key, you'll have an API key for it. And again, under the context of it's increasing our ephemeral storage costs for storing this data tree off chain, but that's a much more scalable cost for a company like this. The example I kind of give people do crudely, if you took every action that's gone into Discord as an application, there's been some some things they've published around this. Every every comment, every new user creation, all of those events, and you wanted to give them verifiable timestamps, we could run that through an architecture like this over the course of a year. None of the on-chain gas cost is changing. The ephemeral storage that is associated with storing those leaves does increase. So that's like the one kind of dynamic there. But it speaks to the scalability of this sort of an approach, because regardless of how many people are using it, the cost that we're paying on-chain is static. You bring up great points around the priority fee. That's something that we'll gauge as it comes to how often we're checkpointing to different chains. But great questions. The other thing that's like really important to take away from this whole thing is like, I've talked about this like centralized API that we operate, and like we are very explicit with those words. Like we don't try to beat around the bush around that. And that's because the architecture kind of empowers this unique degree of sovereignty. And what I mean by that is as soon as you have this Merkle proof, the only thing that is required in order to verify it is to have access to the underlying layer that the root checkpoint was posted to. So that means that like if you're showing this to a party that doesn't trust you, they don't need to like go verify a bunch of signatures. What they need to do is go verify that the root checkpoint that the Merkle proof resolves to landed on chain. Maybe they're trusting an infra provider. Maybe they're running their own light client. Maybe they're just trusting and verifying later, but that's kind of the spectrum that it gives you. But go ahead if you had a question.
For the Merkle proof, the app user has to save themselves somewhere, or?
It's a great point. The protocol is unopinionated around where the proof goes. If someone brings a hash to our Explorer, for example, right now, we're gonna give you a proof if we have it for you. When you talk about sovereignty, though, you bring up a great point, which is like, is an application going to store this on behalf of a user? Are they going to allow a user to exit it? And the key here is that regardless of where this data is custodied, wherever it's stored, that verifiability can still follow it. So even if I'm like hitting a centralized API, like I don't know, like Weather Underground or something, and I want a signature from them that's timely from their API, they can prove that they produced that information at a point in time, regardless of how that data moves around. It can move between data storage networks. It can move between data availability networks through maybe a federated system, like how we're seeing with a lot of the social protocols right now, like Farcaster and Blue Sky. The protocol at its core is not opinionated about where that data gets stored, but as an application developer,
this API doesn't guarantee the availability of the proof.
we wouldn't describe it in the same way that like a Celestia layer gives you guarantees around it, right? Could you optimistically trust us? Yes. But the idea here and the nice kind of property of sovereignty that we're hitting on, and I think you're asking great questions on, is that once you have the proof produced, you have the option to exit essentially. And so if you want, if it gets deleted and you want to come back for us, hey, maybe we still have it, great. But that's not a guarantee that we like discussing around the protocol. It's not one we would like write about the protocol, but a fantastic question.
Another question is what's the frequency of the periodic update?
So it's different between the different networks that we support. And again, this goes into the cost because we're paying that 90,000 gas as many times as we checkpoint in a day. We checkpoint on test nets. I think it's like every 25, 30 seconds. We're checkpointing on base, which I think is our fastest network right now, every 10, but we could probably knock that down. A lot of what we're waiting for there is like to see how people want to leverage this. Do they get value from kind of a higher frequency or cadence of checkpointing? On Ethereum, for example, we're checkpointing around once a day. So it differs depending on the network.
It's the kind of thing where like once the economies of scale kick in of having people using this, it starts to make more and more sense to crank that down because you're starting to basically amortize that UX across a certain number of parties, right?
Yeah.
Still sort of like bootstrapping that initial phase.
Yeah, absolutely. And we're very early in that journey. Like that's kind of the dynamic we have to bootstrap.
So at the moment you're not charging fees, or how do I understand?
Yeah, at this stage in this, like we're fortunate to be venture backed in the sense that like we can go experiment with this primitive, understand how it brings utility to different applications. We're also building applications on top of this protocol as well that we'll kind of demo here in a little bit. But yeah, hitting all the right questions.
If you charge fees, eventually would it be on-chain or off-chain? Or?
We've actually discussed that a little bit, especially because some of these payments can be made cheap enough now. I think we would probably want to accept like a number of ranges there when it comes to like the preference of a user to pay for this. Cool. So the kind of quick TLDR that we have around like how to use Witness, it is really as simple as 3 steps. You're submitting a hash of whatever data format, regardless of size, location, et cetera, that you're attempting to retrieve this resource for, this trustless timestamping. We're submitting a root of this verifiable data structure that allows your proof to be produced and verified by anyone. And then you're having this proof distributed back to you by the server at which point that proof is sovereign for the user. We have a quick kind of like replit demo that we can go through that shows really the SDK. If people are interested in this room and like diving into that, we can go into it now. If we want to skip over it and chat more about like some of the use cases and some of the other things, we can shift through that. Cool. So I will pull up this little demo And I'll kind of describe what this is before we kind of play it, and I'll kind of pause and play through it. But this is an application that we've developed on top of the protocol called Cosign. So you can think of this as like something that could be created leveraging the protocol's resources that it scales. And the idea with this is really to kind of like demonstrate this lazy minting flow. You're doing something off-chain with signatures that leverages the protocol to prevent you from having to pay an upfront and dynamic fee as you're initializing content, as you're performing actions within an application. So what we're doing here is essentially we're logging in with kind of like a Privy-style client, if everyone's familiar with that. We're uploading an image here. In this case, it's from the Trust Info Day the other day. When I click Cosign there, you'll see the wallet pop up here, but I'm basically like, writing my signature on there. I'm saying like, hey, Osprey saw this piece of data. If we go back to that tweet, what's the last thing that we could prove about that signature is like, when was that signature made? That's what Witness is actually going to empower through this flow. So once you see this kind of refresh, you're seeing like, oh, we're kind of pending on chain. What does that mean? We're waiting for that checkpoint to land. So we've submitted it to the API. The API has given us a valid request that it was accepted. And now we're waiting based on these intervals to see it. For this demo, we're leveraging Base, which is their Base Sepolia, which is their kind of predominant testnet. So you'll see this flow actually happen quite quickly, where like we're expecting this Base Sepolia thing to like have already landed on chain. If I go back to the application and give it a quick refresh, you'll see that that button up there actually changes. And I'll take a quick pause once it updates. We've created this off-chain object. We've basically made it so that you can verify what it is, who signed over it, and when it was signed. All of those properties, even though they exist off-chain, are verifiable by smart contracts. And so in this next step of the flow, what we're saying is, oh, Trust Info Day was a banger. It's 2 years in the future, and I want to have the ability to actually compose with this object on chain. And for anyone to be able to verify that, like, oh, yes, it originated at that point in time. That's what this flow is going to demonstrate. But we're not waiting a year. We're going to go ahead and send some testnet ETH, and this asset has been minted on Base Sepolia. Obviously, there, a user is paying a transaction fee to compose with the data when they bring it back on chain. But the idea is you remove that dynamic from the initialization of content. This is just kind of an example of like what the UI looks like. If we think about Farcaster as a protocol, I won't go into the technicals of it, but people are passing around signatures. You have this federated system that is storing your data for you that you're to some degree trusting. Maybe it's on Naynar's servers, maybe it's on Dan Romero's server back home, who knows? One thing here, though, is that as these users broadcast these signatures on the protocol, like a cast, there's no verifiable ordering around that. So, for example, if I wanted to basically make a Farcast and then go throw it to my own hub and start gossiping that information with the network, if I wrote down the timestamp that I made this tweet or this cast 6 months ago, that's what the protocol is going to show users in the interface. So that's kind of like an interesting example where all people are doing are throwing these signatures around, and a way to make them composable with blockchains is to give them this verifiable ordering. And that's that property that we try to extend from blockchains. And so this is just like an example of like, oh, I upload this post. It allows people to interact with it in a different phase. Like, oh, imagine it's like a bookmark or like a retweet or like a super like. And now when I refresh this page, you're going to see that like our interface is kind of contextualizing that signature from that other platform here. And OpenSea's testnet support's a little wonky, but that gives us an idea of it actually composing to the chain. Any questions on the demo? We actually have one that you guys can co-sign if you want to play around with it on this. I think this next slide here. If anyone wants to scan, you can actually like see what this flow looks like. And again, the nuance here is that like since no one's paying a transaction fee, this can be happening like hundreds, if not thousands of times for any scale of users within an application.
It's like a block without malicious chain.
Exactly. It's a great way to put it.
So like the point here is, like in this example, is just to say, okay, I saw this post or I did this post, and to like verify, like anybody can verify it on chain that I actually like did this post.
Yeah. Even though this information exists off chain, you're still empowering smart contracts and untrusting parties to leverage blockchains to coordinate around that data. I'm no longer trusting your signature. I'm trusting something
I
deeper.
need Witness to do that because I could generate a hash of data by myself and then send this data out.
It's actually like a nice exit guarantee of the protocol. Actually, that's kind of what CETA always says. It's like, oh, if we ever stopped serving you or we were serving you like in a bad way, could you go post a hash on chain? Yes. If you wanted to go post 1 million hashes per user, or if you wanted to achieve it at that scale, then you're exposing yourself to that like dynamically priced market.
And what you're doing is like proof aggregation. Like it's the same thing as what Libra or Zine or LLA are doing. Is like you're amortizing.
We don't want to sound as big brain as that, but yes, pretty much, yeah.
I would say the aggregation element of those systems that you mentioned are somewhat similar in the sense that we're saying, hey, we can consume this constant resource and attempt to scale it to many, many users.
And what are some of the like largest use cases that you see in your mind? Like, what is your vision for your protocol in the
Yeah.
future? Like, what could it be leveraged for?
Perfect segue into this slide. Why do we think this is cool? Which is a great question. The first is kind of the on-chain composability aspect of this. So right now, you can have a smart contract verify a signature over a piece of information, but unless you kind of have a protocol like this that can scale this existence resource, it's actually quite difficult to verify the timeliness or ordering. That means that people can think differently, in our opinion, about things like open editions, like lazy minting, so that more parts or components of an application that might be quite granular, things like likes, things like proofs that people aren't or sorry, not proofs, but posts that people wouldn't even think to mint today because it's too expensive, there's too much friction. This allows them to think differently about, hey, I can actually anchor this information to the chain in a very scalable way that has the potential to unlock some kind of novel composability. Things like enforcing fees, things like allowing for fungible assets to be produced from these timely proofs. It's one kind of aspect that we think is interesting. There's also a lot of excitement recently around people experimenting with attestations. The way to think about this is that something was said by someone at some point. Attestations can actually be custodied off-chain in a fully verifiable way using a protocol like this. And we think that means that people can experiment with a different scale of attestation designs. There's also this aspect of data portability between applications. Because you can verify the timeliness, you might be more willing to coordinate with with data produced by another application, because you know that they could not have backdated this information if you're expecting for these signatures or these proofs to be present in the data sets that you're trying to move around or that you're trying to compose with in an off-chain manner. There's also this element of just incentivizing data to move on-chain. I make this joke that I think we were saying it when we walked in the room, everyone's thinking about how I bring applications and users to pay for my chain. I don't think as many people are thinking about how you extend the existing guarantees of blockchains to the rest of the internet, as we kind of described with that graphic. And we think that's an important thing to try to kind of accelerate when we think about how society, the adoption rate for society, coordinating using blockchains. There's also just this general aspect of trustless timestamps at scale. I think the nuance here is that except for maybe 2 or 3 systems that are widely adopted across the modern internet, every timestamp you see is a signature from some trusted authority. The exceptions to that are a system called certificate transparency, which many of you have probably used hundreds of times today. And it's what empowers you to essentially have that green lockbox pop up in your browser. If those SSL certificates aren't included in a verifiable data structure that your browser is literally requesting from a publicly available log, your browser will not accept it. And that's what basically brings accountability to that system if one of those authorities misacts. So it's an example of an immutable trust log that leverages these sorts of concepts, and candidly, that is what's scaling the majority of modern encryption on the internet today. Another example is the Apple keychain, if you're familiar with how that system self-audits itself. Basically prevents the kind of rotation of signer keys for the entire iMessage platform as a protocol. And then the last thing, I briefly mentioned this, but this API interface is only seeing these hashes. What does that mean? It means that you can make private but verifiable commitments at scale, and we think that that also has some really interesting externalities. So I have some resources here, and I'll probably be sharing this on Twitter as well, so people can reference back to the presentation. You can play with cosign, mess around with the docs. We have a quick start on Replit, as I mentioned. That's you can fork and be using this API in less than 2 or 3 minutes. And yeah, we have a developer chat in Telegram where we're bringing people together to chat about these ideas, help support them if they're interested in leveraging the protocol, ask questions, et cetera. So if any of you are interested in joining us there, definitely feel free. So we have some other slides if you guys have questions. I think we have around 10 or 15 minutes if you have more to chat on, we wanted to. And yeah, I appreciate you guys taking the time to listen. Yeah. Thanks, guys. Anything else? What was your name, by the way?
Philip.
Philip, it's great to meet you, man. I appreciate you.
I have a question regarding, you said without upfront gas fees, what do you mean?
So,
Because somebody needs to pay.
yeah, so don't get me wrong. The protocol is paying that gas fee every time that it goes and updates on chain.
So if we're talking about
No worries, come on in.
so there would be a user that uses the protocol, and the protocol integrates your app, uses your API.
So let's think about you submit 1,000 hashes to as a developer.
Who is you?
Me is witness as a think of this as a when you think
It's me then.
Your POAP. Your POAP.
your POAP.
What is POAP? POAP is a
application.
You're making attestations,
Okay.
right? You used to mint on, Gnosis, now you make on witness.
Okay, so I'm in an app which is called POAP, which has users.
Yep.
And users do actions.
Correct.
And these actions trigger your ID.
Correct. That's the way to think about
Which
it.
is
It's
a
like-
hash submission to us, basically.
Exactly.
They get added to this Merkle tree, which gets checkpointed on chain. And the punchline there is that the user now has a verifiable, like sort of effectively a lazy mint without POAP having to have paid Gnosis chain over the hood. Right now, Gnosis chain is paid like, a couple cents every time they mint something. Bless you.
Thank you. What do you mean they don't need to mint? I don't fully understand. So it's like,
So for DevCon, they have a discount on tickets if you have a POAP from DevCon of the previous year, right? One issue with that might be that if I was the organizer of DevCon a couple years ago, I might have some secret POAP codes that I can go mint now and give discounts to my friends. But, because in that case, you're effectively trusting that this person is creating these trusted attestations. If you have one of these attestations, we know you're at this event. You can imagine a world where all these POAPs are sort of actually forced to be verifiably timestamped on chain, either via directly being minted or via having one of these off-chain proofs that rolls up to the chain, where now you can effectively prevent against this, prevent against backdating effectively, which is in a lot of cases what makes an NFT valuable in the first place.
so what you're doing is like, instead of having to mint things on chain, you can say like, okay, I actually clicked on this button, which is what was the mint button at time X.
Yes.
I have this name instead of on chain, so you don't have to mint anything anymore. Like,
It,
you don't-
it depends on the utility you get for the mint, right? There's kind of two things you get when you post like an attestation on chain. You get this verifiability of when it happened. Another thing you get when you're actually like posting the NFT fully on chain is this nice data availability property. The data availability property is important because it allows any indexer that's watching the chain to actually retrieve that information and store their own copy.
But what do you mean? Because at the same time, I'm like, okay, if I posted the proof on chain through your service
Yep.
as a user, and I don't actually need to have the NFT in my wallet, I don't really care because I can generate proof that I actually have it.
That's exactly what we're
You're
saying.
basically thinking of it
Another
the correct way.
service
Yeah.
and say, okay, I actually have it because this is the timestamp
Yeah.
that I gave you the proof.
Yep.
So actually, like, I never really need to mint anything.
That's kind of the punchline here, is that there's a lot of sort of NFT sort of looking use cases where all you care about is exactly what you said, being able to prove to someone else that like, hey, I was here at a certain point in time, or that I took that action at that point in time, right? Now, if I have to pay gas for all of those things, maybe I'm capturing those moments a lot less, versus what we're arguing is that you shouldn't have to pay gas for it. We can aggregate in a Web 2 way, we can upfront sort of stomach that Web 3 portion of the cost, and now all of a sudden sort of this new little like UX primitive that Web 3 can have. We use the phrase lazy minting because I think that's really what this is, because you can bring it back on chain and make a proper NFT out of it. It's just the phrase lazy minting has been around so long that it's kind of diluted.
But why would I mint it then?
Why would you mint it?
What
Because,
do I benefit from it?
because imagine all of a sudden that POAP from a long time ago, not only do you want to prove you had it, but your friend wants to buy it from you because it's a cool collector's item. And so now you sort of, it's almost like having the option, but you don't have to mint it, right? This is one way to think of it.
The dynamic here is that if you want to do a stateful action with this asset, it needs to be more composable on chain, but the idea of having an upfront fee market to initialize data in a verifiable way is kind of, I think, the thesis that we're kind of testing.
I have a question also around the generation of the proof. Like, how do I prove that this proof belongs to me?
So it's basically you have some data, right? Think of it as like a data schema, some JSON, whatever. You hash that data, and then we give you the Merkle proof, and that all basically just connects up. So depending on the data schema, you may or may not be able to claim ownership of it, right? So one data schema might just be an image. Another data schema might be an image with a signature, right? That's kind of what that cosign demo is. It says, hey, come sign your image, and now you can sort of claim some ownership over it, right? If no one else has an earlier signature on this image, that's kind of a good like indicator that you might own this image or create this image or however you want to say it.
So is it like each app would have their own mountain range, and then you would like aggregate this into a final one?
Right now, we just have one big Merkle mountain range, but potentially designs like that might make sense too, just depending on different trade-offs. Yeah.
The thing to think about is that if there's essentially hashes that you want to provide for two different trees, you're now paying that 90,000 gas usage twice. So there is an element where, like, if someone came to us and we're like, hey, like, we'd love to see this system operate for like a personal tree with like a different type of verification logic, something like that, something we'd be interested in. But a lot of the economy is of scale for this like lazy minting use case is like, listen, we can use this really fat, beefy Web 2 system that, as you can hear me talk about it, like there's nothing we shy around from it when it regards to the centralization and sovereignty of that component. But the utility of this is that once a proof has been provided to a user, that proof is sovereign. It might not be available somewhere, but there's still an ability for applications and smart contracts to compose with it because it's as verifiable as it possibly could be. You can verify all three of these properties that you could potentially verify about data, even if that data is stored off chain, even if that data is provided to you by a party or an indexer or a data provider that you don't trust.
If you're a user, and then you have a certain piece of data
Yep.
that improved at time X,
Yep.
and that is now living on Ethereum or on Base. The problem, like the way to retrieve this data is to generate a Merkle proof, right? But to generate a Merkle proof, then you need all the the leaves, like
Correct.
this one, this one,
Correct.
this one, and this
Correct.
one to generate the
Correct.
up to the root, right?
Correct.
And so, if I'm a user, imagine we take an example where we have, I don't know, any Web2 service, like let's say Coll or YouTube
Sure. Yeah.
wants to do that. And the problem is that if I'm a user, I might not have access to all the other leaves, right?
Yep.
So I wouldn't be able to generate the learning proof.
Yep.
So how do I do it?
So I guess our sort of thesis here is that you have the option to custody that data yourself. So again, once a checkpoint lands on chain, you could request the proof from us and we'll serve it to you. And so from that point on, you can choose to store it yourself. You can throw it in your Google Drive. Maybe YouTube as an application stores it for you as well. So there's kind of that dynamic. And kind of our underlying thesis is that even if you're using a normal DA layer, a user is going to be querying via an indexer or some centralized API anyway, right? And so the thing that actually matters is the verifiability. And so even if it's not on a DA layer, but you still have the DA and you can verify it, like you have the data, so like data availability kind of stops mattering at that point because you have the data in your own hands. That's kind of like enough in a lot of cases, effectively. And then you're not paying that dynamic DA fee that everyone else is paying.
Well, what they didn't get is like,
Yeah.
maybe if I'm a user and I have a certain piece of data,
Yeah.
which is like my name,
Mhm.
timestamp, and an image
Yep.
that I wanted to make.
Yep.
And then there's YouTube.
Yep.
Like there's a POAP, this is a POAP app, and it does millions of actions with other users that do the same thing.
Yep.
And then all of these actions are sent to your service as hashes.
Correct.
And then you aggregate them into this Merkle boundary range. And then you take the root of this Merkle boundary range, and then you post on chain the root of this Merkle boundary range.
Yep.
The thing is that I as a user has never had access to all the other leaves.
Yep.
Right?
That's
So
right.
I will never be able to retrieve data from the root that you posted because I will not be able to generate the proof.
We serve it to them. So we call it like a 30-second trust assumption, where effectively show the little ping pong. Go up a couple. This one, yeah. So basically, like when this flow is over, you're good. But you're right that during this flow, there is a data availability problem. But the punchline here is that we're not doing anything complicated where we might embed you, we might front run you. All we're seeing is a hash of your data. And so assuming, in the 10 minutes it takes us to land a checkpoint on base, that our incentives don't change and we decide to censor you, we'll give you this proof at the end of that, and then you're good. So that's kind of the point here, is that like,
We call it this trust window. And again, we're not shy about this. Like, this is kind of what the architecture is somewhat designed for.
and once you have your proof, you're good. When we post updates to the tree, you can keep your proof up to date, your old proof is still good, both of
It
them.
goes back to the fallback you said earlier as well, which is like, imagine we censor you, the centralized API censors you. You could go pay the dynamic fee on chain if you want to go broadcast this hash. But the idea is we're giving people this alternative that can actually have, scale and be free. Cool. A great question though. You're like really hitting on kind of like, where are the trust boundaries? When is this sovereignty actually like guaranteed? And obviously you're hitting a lot of the nuance here, and part of the reason we appreciate like you guys engaging with us on this is describing some of the dynamics here versus some of these architectures that people are familiar with when it comes to blockchains, when it comes to DA layers. It comes down to the guarantees that they're providing, and one thing that's key with Witness is that it's that data existence resource that we're scaling. We're not giving you a DA guarantee or a data storage guarantee on the underlying data. We believe if you make that verifiable, those things can happen naturally or even in centralized ways that still allow people to coordinate on that data in important and composable ways.
So your vision for it is that like Web2 services will implement something like that, like YouTube will like transform all their database into a Coll
Yep.
tree,
Something
and
like
then
that.
be able to
I think like trust like trust minimized like audit infrastructure is something that this can really empower with. We go back to the idea of certificate transparency, et cetera. Like these things are live in production today and empowering a lot of how all of us use the modern internet. You wouldn't be able to solve Byzantine generals for symmetric key generation, for example, in SSL unless you had one party trusting the other first. Why is your browser trusting that directory? It's because there is a certificate that was issued in a way where if the certificate authority was bad, anyone can audit it. Your browser can audit it, almost like a light client. And so allowing people to kind of create these timely proofs that are verified with, like basically no intermediary once you have custody of it, we think is a very, very interesting design that can empower, a very different future for the internet.
Do you have some example of, are you already live?
Yeah, so we have like a number of different protocols that are leveraging this today. We have a few that we'll be able to get somewhat loud about like here in the coming months as well, which we're kind of stoked for being the kind of first production use cases. We kind of bucket it into 3 groups. I'll kind of broadly describe them. The first is this lazy minting use case, brands, et cetera, that are thinking about minting on chains that their users care about, potentially multiple chains, but in a way that they're never having to worry about this dynamic upfront fee market that is out of their control. The second use case is this kind of trustless timestamping thesis where there are entities that generate different types of off-chain data. Maybe it's a legal contract, maybe it's some sort of attestation or guarantee, allowing them to audit how they're generating that data, and different Web 2 systems can be very valuable for them. So there's a number of different use cases we're experimenting with there. We're also quite excited by some of the teams that are looking at existing Web 2 signatures and essentially trying to find ways for those to compose in trust minimized ways with smart contracts. Some examples of this are like the team at, I think it's ZK P2P or like the ZK email team. They're leveraging aspects of this system to create essentially trust minimized infrastructure around essentially the signatures that are being verified as valid because they're coming from these DKIM headers and these emails and they rotate over time. So timely signatures become very important for a use case like that. Another one is kind of the excitement that we're seeing around ZK TLS again, I think over the past couple months. Essentially trust minimizing some of those infrastructures. This protocol has been found valuable by some of those teams. Yeah, I really encourage you all to look into both of those directions as well. A cool thing about those is that if they can be trust minimized in a proper way, like there's no consent that's needed from the generator. So this is like the thesis that I think people have been preaching for a long time in crypto, where it's like we're going to be able to import all of our Web 2 data into crypto networks finally, or kind of compose with it, versus like trusting a gatekeeper or trusting a signature from a Spotify server, whatever it is. I think that's going to have the potential to kind of like allow users that aren't even on blockchains to kind of come to blockchains with something. They already have generated this valuable data, and now smart contracts can compose with that in a verifiable way. I think there's really, really cool, new, interesting, maybe a little bit pie-in-the-sky vision for applications that can be built on those primitives.
Cool. So basically, what are your trust assumptions? Like you have like
Liveness, basically.
Yep.
liveness and just censorship.
Liveness until you get approved. Yeah.
Yep.
Censorship.
Yep. And again, the reason we think that's acceptable, and again, like that's our opinion, that doesn't mean it's acceptable for everyone. The reason we think that's acceptable is because of the economies of scale you get of the system, first and foremost. The second is that trust boundary, as I kind of described here in this first bullet point, is bounded in time. Again, you're waiting for a checkpoint to land. We don't know what you just checkpointed, so we don't have the underlying data of your hash. Like we couldn't go like try to claim ownership of it because we don't even have the data on it. And obviously, like again, we're only receiving a hash. The incentive for censoring a hash versus censoring like a stateful transaction is very different when you get into like the MEV dynamics, et cetera, around that.
I mean, you could still like imagine you have something that like a big launch, like something like board apes or something like that. Then you could definitely try to shut down your service or like
Absolutely.
And
There's long tail mev always. Yeah.
There's always long tail mev. I think you see that a lot when it comes to the adversarial mindsets of like, whether it's like fake employees applying for my job applications or someone not liking the network my API operates on and trying to crash it. You definitely bring up a good point, which is like, you still need to think about like cyber resistance and kind of spam protection for a system like this. There's a few ideas we have.
We'll say that. True storage, like because you send back the truth to the user, but then how does he store it?
So we've obviously considered building like light clients and stuff like that. Maybe like a little Chrome extension or a Google Drive plugin that like backs it up for you. We're still kind of early stages in that regard. So for now, when people use this, we just say, hey, our API is going to serve it to you for as much as you need. Some of our clients, as we checkpoint stuff, they also just get the proofs and store it in their database proactively as well. Some of the clients just read it from us when they need it. So it's been all over so far.
So you store each and every proof that
We have the whole
Each
tree.
and every leaf, we have the whole tree.
We have the whole tree. So don't think of it as like we're storing the proof. We have the tree, and we can just look up the proof as we need it.
Okay, because if you didn't store the tree, as a user, I lost proof, then you're kind of
Effectively, yeah. I mean, that's what the vertical tree does, right? Yeah.
But the problem is that it's not even really only like censorship resistance and liveness your problem. It's like you also have this very problematic thing of like you're centralizing this tree, and this tree that cannot be recomposed. It's like if you lose this tree, then all the users that don't have their proofs, like it's finished. When, for example, if you take a blockchain like Starknet, that posts their state transitions to EA, then even if Starknet shuts down and all the sequencer shuts down, you can still reconstruct the state from the DA, right?
To an extent, DA only persists for a couple
Yeah.
weeks, right? But according to the incentives, then beyond there, it's a one and end.
It's a one of the
I would say ours is
because
the
you
same
publish,
as
any
others.
indexer could have stored it. If the network shuts down, it becomes a question of which indexers are still storing it.
But I mean, it's still on the DA, right? So you could recompose it.
It was at a DA at one point. So presumably you could compose it because it was available at one point. But when you're querying it now, when the DA from a year later, that's not still on a DA layer. You're querying that from index.
Then from you, if you lose the tree, then the users are kind of fucked.
Say again?
If you lose the tree, then the users are kind of fucked.
So because the checkpoints are landing on chain and that's what you need to verify this proof that we claimed you're sovereign with, you're right. Could the proofs be recomposed? No. If a user still has their proof custodied, are they still sovereign with it and have an ability for anyone to verify it? Yes, because the read verification does not require any dependency on the tree even existing or us even serving you. So you're asking all the right questions there around the trust boundaries. That is really a lot of the nuance here.
Last question.
Of course.
Would it be possible to lie for you, like serve you a hash that has a certain time? That is like, who does the timestamp? Like, is it you or
It's the chain.
It's the chain. Okay. So
We just give the chain a really juicy root hash to notarize. And then we give people proofs that
Their hash rolls up to that notarized hash.
And how does these hashes store value? Like, because like a hash only, like a proof only has value. Like how do you say that? The proof bears value like inherently because it's a proof. Like this value can only be extracted by the verifier. Right? You need a party that will accept this proof as bearing value.
Of course.
Right. So if I have this proof and nobody's ready to accept it, then it's useless to me. So it's like I need a protocol that will accept my proof and be like, okay, this proof is valid, and I will give you money for it, or I will say that you can now mint this signature. Okay, so you need to be integrated with all these protocols and make sure also that these guys they respect their promise, because now the problem is that I'm sovereign on my proof, but I'm not sovereign on my NFT. And so because I don't really hold the NFT in my wallet, then if the protocol at one point sees, for example, let's take this example, there's a Bored Ape launch, and when the Bored Ape launched, I don't know, it was $10 to mint one. And then I generate all the guys they mint using your protocol, and they get these proofs of like, okay, I was there. And then the price 1,000x or 1,000,000x. The protocol, like Yuga Labs, maybe they're gonna say, no, we're not gonna let you redeem your proofs for the mints because now maybe next. So it's better for us to keep those and actually sell those than to accept to value these proofs. Right? So you can have like very big problems like that in case you have like high price variation.
Yeah. You definitely still need to consider like traditional like upgradability stuff like that with regards to like the Web3 happening.
Yeah, but like one way to think about it is like imagine before they start issuing these proofs, they've launched their NFT collection still. Yeah, thank you, man. I appreciate it. I think how a lot of those flows would work is the first thing that's happening is like before I start issuing proofs, I'm gonna make an NFT contract. I'm gonna deploy that contract in an immutable way. That contract can basically can enforce different things about this data signed message that you're bringing back to it to mint your NFT. So for example, it can say, hey, I want to verify that this was issued by Yuga Labs and that it was issued before this time for it to be valid. That can be an immutable contract that they launch. They start giving out their proofs. The users can basically say, like, yes, I could go mint this whenever I want. And it stops Yuga Labs from minting more after that expiration time. So it allows you to enforce that. And so I think the dynamic that's important to understand there is that like, again, what this is saving costs for is like initialization of these things, and there's still ways to like essentially launch contracts that can compose or incentivize these proofs or this data to come back on chain. There's ways to enforce that rule into data schemas without having to pay an upfront fee for it.
I think I don't know, in my mind, like, I feel like I have an intuition for the potential, like it seems interesting. I feel like it adds a lot of like complexity.
There is an aspect of complexity it can add.
Architecture, or like the smart contract developers need maybe to add some things, and then you have these games like that happen. And so I'm just curious, like, can you give us like a banger application? Like, do you have in mind something that is like Google, you find anything that you want in one click? Like, do you have something like that with your thing? Where it's like, okay, this is the application, like, okay, our protocol is made for that, and if we do that, it's amazing.
Yeah.
I think when we say mint everything, I don't think it hits people's ears the right way. When I say mint everything, what I mean is that your phone has a radio, right? Talking to the Wi-Fi, it knows there's other Bluetooths around. I'm talking about at that granularity, minting every single interaction so that when you're doing some KYC in the future, you can prove via some kind of, like the captures, like they capture your mouse movements and via the minutia of how you move your mouse. It's like this is a robot or a human. I'm talking like that level of granularity, provable to the chain in real time as like a continuous alibi. Like, look, I'm a human because I have 18 years worth of like human-like activity that could have been faked because it was done in real time. I would have had to fake it all the way starting 18 years ago. So like that type of granularity of interaction that then, how does it actually manifest into value on the chain? That's a little bit more like pie in the sky. Maybe I'm doing some ZK proven like identity thing. Maybe it's some KYC world thing. That's kind of like where my headspace goes in terms of like what scale this could hit and where it actually gets useful compared to like throwing it on a cheaper DA layer or something like that. Like you would never be able to put all that data on a DA layer effectively.
So like the slogan would be like prove everything, like every single interaction that you do.
If it's not on chain, it's not real. I mean,
Or if it's not on chain, then there's some element of the data that cannot be verified by you as an individual, by the entity you're trying to coordinate with, maybe by an AI agent in the future.
yeah, I mean,
Literally, that's the funny part, I think. Like that analogy, I think, hits for people that are, yeah. If
I said if there's no SSL, don't go to the website.
like imagine you go to a website in that lockbox that you're like, I don't trust this, get me out of here, right?
You're not gonna like do anything.
Yeah.
Now imagine all the timestamps you scroll across as you just check your email, check Twitter, and you're just like, well, Twitter told me that he posted this yesterday, so I guess he must have. Which Twitter doesn't have a reason to lie, right? But as the incentives get crazy, as AI gets crazy, like
as the acceleration continues.
yeah. So if it's not on chain, it's not going to be real. Why would you trust it if it's?
We have some blog pieces as well if you want to read into like some of our like, hey, like don't talk to me about how this works, but like why does it matter? Yeah, I think this framework has really hit for people where it's like, if you show me a piece of data, there's only 3 things I can potentially verify about it without trusting anyone that can allow me to ascribe some sense of authenticity to that data object. And those 3 things are like, what are you presenting me? Who signed it and when did they sign it? There's not this like 4th magical property like, oh, this thing is authentic, this thing is a deep real, this thing is a deep fake. You need the context of these things, and by taking all of these signatures from all these validators across the networks that we operate this thing on top of, we're able to produce this kind of verifiable timestamp at a scale and in a way where we think it empowers individuals, we think it empowers people to think differently about how their applications compose, et cetera. I think another one I get excited around is like journalistic integrity. I think you have to think hard about the incentives there to like help those entities kind of like self-regulate themselves for some, for different reasons. But ironically enough, there's like individual entities I think that are interested in that. So like independent journalists, et cetera. Anybody? Alrighty, I think we're all good. Thank you so much.